Thank you very much, Martin, for the introduction, and thank you very much to the organizers for setting up this and for the opportunity of being here. So we want to talk about this Mathart Sonification program, which is not precisely music, but it is very close to music. So a little bit of our backgrounds. I am a mathematician. I studied aperiodic tilings. And I learned to draw them with Python, and this is how I got to get into generative art, and this is how I met Jaime. Jaime is a musician, a compositor, a multimedia artist, and multidisciplinary artist, and he has some projects with art and science. And we met and we started talking, and we realized that both of us had ongoing projects in which a collaboration would be very helpful for both of us. On my side, with a project for communicating mathematics through art, and on his side for creating art pieces inspired by science, and particularly math. So the kind of things that we are considering is that there is already a theory of sonification of the data. And there are these two books, the Sonification Handbook, which is actually a German book. You can download it from sonification.de. This is from 2011, and this one is from 2019. And they are very similar. These two books are very similar in the sense that they are divided in parts, and with a theoretical part and a practical part. And in the practical part, they show techniques and technologies for sonificating that data. And in the theoretical parts, they consider stuff as perception and cognition and aesthetics. But both of them basically conclude that they want to go towards a data sonification design framework, like they want to foundate the theory. And one other text that we've been discussing is this Letter on the Blind for the Use of Those Who Can See, which is a text by Denis Diderot from mid-18th century, where he poses some questions about the non-visual perception of mathematics. And he talks about this character, Nicholas Sanderson, which was a blind mathematician from early 18th century also, and a method he developed for teaching and learning mathematics. And these questions really make us think about how this idea of sonificating mathematics could be helpful as a perception tool, not only for blind people, but also like an extra dimension of perception. And also, of course, we are thinking about this project also as an artistic discipline, just with the goal of creating some art pieces. So I'm going to show some very basic examples that we started with, more on the extreme of, we have these two extremes, like this sonification of mathematics, actually extracting the sound out of some mathematical objects or procedures. And I'm going to start with that. I don't know if you can recognize this, but this is actually the process for solving the Hanoi Towers. We assign a different octave and in this example that I played, there were 4 disks, and we assign a different octave for each disk, and the 3 sticks are 3 fixed notes in an octave. So depending on the amount of disks you have, is the amount of octaves you have. I hope you can see the process of solving the Hanoi Towers. Another example where we think we can actually hear the mathematics behind is this one. So here we have just a pattern repeats, what we are listening here is actually the symmetries of the freeze patterns that Paulo mentioned in a talk before earlier. And here we have the 7 different symmetries, and we can create musical scores. And we claim that you can actually hear the symmetries here. A third example, we start with a triangle, and we say, what does a triangle sound like? Well, if there is an equilateral triangle, and in each octave we have 12 notes, we arrange these 12 notes in a circle, and we put an equilateral triangle on this circle, and this would sound something like this. And if we have an iteration rule, we can follow this idea and next iteration. Just one more, but I have to move this. Maybe this one is a little bit trickier, but what it is sounding here is actually the construction of the Koch snowflake, and we are just following the rules of the L system, the way it is constructed, this fractal, and we are converting these same instructions for constructing this fractal, but we are turning it into nodes. So if we want to take this idea a little bit further to the creative part, with this same input, can do something like this. So here maybe Jaime would want to join me.
Okay, before you play it, I would like to say something. So we were working in this seminar we have been like having for almost 1 year. One question about what could be the rules of sound text to be considered as a scientific tool. No, the idea of algorithmic composition and also music driven by data, it's like very, very old. One of the first examples I have found is an algorithm by Guido de Arezzo. He poses on 1023, something like that, to making an exercise for improvisation where you can have any text and substitute all the vowels for notes and rhythms. No, so this has been like very important branch of composition from whole history. Another example is maybe the musical dice that were very popular in the 18th century. One of the most popular examples is the musical dice composed by Mozart. And also, well, in the 20th century, we have several examples, such as Yanis Xenakis or Julio Estrada, working with algorithms and data-driven composition. So we want to find a difference, an epistemological difference between art and science, where they have something similar, or where are they very, very, very different. So the last example you hear is a mapping of this Koch iteration function. And of course, you can hear all the layers put together, and you can imagine the iteration in the process. But we also have been working on more strategies to enhance multidimensional perception. We have found that what could be something interesting, or what could be a very good tool in sonification data, where we can for the moment we have found two very important things about sonification. One is when you have very several, or like a lot of information and very complex information, um, making a visualization of data can be a little tricky, because there is so much information that um, you cannot get the different dimensions you can have, no? So with music, especially with timbre, you can have a lot of, it's easier for a person to understand multidimensional spaces, that this conceptual barrier we have about seeing the life in 3 dimension. So one is that, and the other is the timbre. So we have make, in these examples you are going to hear, you are going to hear an example mixed for binaural mix. So I recommend you to hear it with headphones, because this binaural mixing allows you to understand space in the track. So we added two extra layers to this example. One is one different timbre for each iteration, and the other one is the space. So if you can play it, please. So what is happening in this example is that the first layer is played by a cello. The second one is a French horn. The third one is a clarinet, and the last one is a glockenspiel. and one iteration is going to the left, and the other one is going to the right. The first one to the left, the second to the right, the third one to the left, and so on. So then you can have you can help your brain to understand all the things happening at the same time. What in this example, we are really trying to help the listener to get information about the mathematical object. We are like trying to stick to isomorphic mapping. But in the next example, we are moving more into a compositional usage of this function. What we are doing here is making based on a generative grammatical algorithm. We are using it as as a theme to generate a pattern and use it for making a composition in several layers. We don't care so much here about the understanding of the function itself, but it still is quite clear. We make some poetical license in this composition, so we can help the composition to be more interesting, because also we have found that that this isomorphical mapping sometimes is kind of boring, and we are wondering if this actually helps or not the text to be more like as more scientific or not. Please, if you can play it. And in the last example, we are still using the programmatic tools we have developed. We program this with Python and Super Collider, but we are just using the idea of fractal and L system just as a poetic concept. We are still using the sequence in some ways, sometimes backwards and sometimes just pieces, as for example, as composers use information in fugues, for example, but this just try to help the listener to understand fractality in a more poetic way.
Okay.
Yes, please.
Wait. Cannot move the. Yes.
And well, there are still a lot of cognitive tools we do have as humans at hand that we don't use so much. So, for example, one of them is human echolocation, the interpretation, the comparison between direct sound and echoes and reverberation. It's also a thing that we can use as humans, but we haven't developed it so much. So there is a lot of opportunities to try to like teach maths, develop pedagogical tools, but also tools for mathematicians and researchers to keep thinking about the abstract world through another way of posing abstraction through sound and music. And also, well, another thing we have found a lot in the scientific sonification of data is that in general there is I mean, for making a interdisciplinary work team of work, it's important to have also artists and composers, because a lot of sonification we have found are just stuck with the division of the octave, the occidental division of the octave, but this is not just like something posed by nature. So trying to not be stuck with notes like do and re and mi, we can help also the listener to understand more and more the dimensions in the information. And thank you very much for listening to us. If you have some comments or questions,